Hey student, this is lesson 10.5, trigonometry and area. In this lesson, we're going to learn how to find the areas of regular polygons and triangles using trigonometry. Go ahead and do the review here, and I'll check back with you. All right, so you're gonna find that we're gonna need some trigonometry here to help us out with finding the areas, and that's because in this problem we're given a regular octagon, but we're not given to find the area of a regular polygon. We use the formula area is 1/2 the apothem times the perimeter, and when we're only given the side of this regular octagon, the only thing we can find right now is the perimeter, so we actually need the apothem also. So I'm going to just draw in a couple lines here to help me out with this. So I'm going to go from the center to the vertices, and when I do that, I end up with an isosceles triangle. I'm also going to draw in the apothem, and that bisects the bottom side there. So after I do that, I end up with this little part here being 3.75. And I also can find the angles in that isosceles triangle. I know that all these isosceles triangles would be congruent. So the angle, and let me label this here ABC. So the measure of angle B is equal to 360 divided by the number of angles there would be, since it's an octagon, that's 8, and that's 45. Okay, now that I know that angle B is 45, I can find the measures of angle A and C also. Since it's an isosceles triangle, they're equal, so the measure of angle C is equal to 180 minus 45 divided by 2, and that's 67.5. Now that I know that angle C has a measure of 67.5, I can use trigonometry. The tangent of 67.5 is equal to the side opposite of angle C, which is the apothem, divided by the adjacent side, which is 3.75. And then, so solving this for A, I get A is equal to 3.75 times the tangent of 67.5 degrees. All right, I also need to know the perimeter here, and that's just the number of sides times the length of one side, so that would be number of sides is 8 times 7.5, which is 60. Now I have everything I need for my formula. I have 1/2 the apothem is this amount here, and I'd suggest leaving that. Don't round that until you have to. So we're just going to leave it 1/2 the tangent of 67.5, and then we have to multiply that by 60. I'm going to use the calculator for that. So on my calculator, I just typed it all in as one expression, 1/2 times 3.75, tangent 67.5 times 60. Make sure you're in degree mode. And you end up with 271 point, about 271.6. And since it's area, that's square centimeters. All right, you try that. All right, a gazebo at a park has a floor shaped like a regular hexagon with a radius of 6 feet. What is the area of the hexagonal floor to the nearest square? Well, make sure you understand that the radius means the distance from the center to a vertex. So there it is. All right, so first of all, let's go ahead and draw this in. And if we think about that, so one of these angles, let's label this angle AB, this triangle ABC again, and we'll draw the apothem in there, and we'll label this D. So this is our apothem there. The measure of angle B is 360 divided by 6, which is 60. And this is also 6 because that's an isosceles triangle. So there's actually an equilateral triangle in there. And that tells us that AC is 6, so DC is half of that, which is 3. And the other thing we know about equilateral triangles is all the angles are 60 degrees. So we know this angle here is 60 degrees. So if we use trig again here, our apothem, trig ratios, the sine of 60 degrees is equal to A over 3. And so A is equal to 3 times the sine of 60 degrees. All right, our perimeter is the number of sides, which is 6, times the length of one side, which is 6. So that's 36. So we now have everything we need for the area. We need 1/2 times the apothem, which we just found is 3 times the sine of 60. And then that times the perimeter, which is 36. I'm going to go ahead and do that on my calculator. Sorry about that mistake there. This is actually, should be the tangent, 60 degrees there. So let's fix those. All right, so on my calculator, I did 0.5 times 3 times tangent of 60 times 36, and I got 93.53. This is about 93.53. And it says to the nearest square foot, so we're going to say it's about 94 square feet. All right, you try that. All right, we can use trig to find the area of a triangle if we have 2 sides and the included angle. And it goes like this. The area of triangle ABC is equal to 1/2 B times C times the sine of the included angle, which will be C. Oops, got that wrong. Sine of A. All right. So what is the area of this triangle? So the area is equal to 1/2 BC times the sine of A, which is the included angle between those other 2 sides. So we're going to do 1/2 times 8 times 12 times the sine of 36 degrees. And using our calculator to do that, we get about 28.2. So we're going to say, let's just round that to the nearest whole number. We'll say it's about 28 square centimeters. All right, you try that. All right. So that gets us up to the lesson check. Go ahead and do that, and we'll talk about this next time we meet in class.